alkynes also undergo addition reactions. They usually happen a little bit slower. Here's ethyne, and if we add bromine, the bromine will add one bromine to one carbon and one bromine to the other carbon. This is giving us trans 1,2-dibromoethane. The first addition is usually trans, it's not cis. And we can add to that again, and now it doesn't matter which bromine is which because they're all basically looking the same. And so this would be 1,1,2,2-tetrabromoethane. They can undergo hydrogenation. Just like with the alkenes that require some sort of a catalyst, usually nickel or platinum will completely hydrogenate the alkyne to an alkane. So here's the alkyne with the triple bond. It's going to add 2 molecules of hydrogen. It's going to add 1, and then why stop there? The catalyst is there. The alkene that is formed also reacts with hydrogen, and so it goes all the way to the alkane. Does that make sense? You want a picture of that? No? Okay. If we don't want it to go all the way to the alkane, there is a special catalyst called Lindlar's catalyst. It's a special palladium catalyst that can control the hydrogen addition. And so you can stop with just adding 1 mole of hydrogen to 1 mole of alkyne. And it's going to give you a cis alkene, not a trans alkene. If we have if we have unsymmetric triple bonds and reagents, then Markovnikov's rule is followed. So in this example, this is an unsymmetric molecule and an unsymmetric reagent. The hydrogen will add to carbon number 1 because carbon number 1 has a hydrogen. Just like people, hydrogens like to go where they have friends. The bromine is going to add to the other. So that gives us 2-bromopropene. Now that can also undergo addition. The hydrogen is going to add again to the first carbon because the first carbon has 2 hydrogens, the second carbon has none. And the bromine then ends up on the second carbon where the other bromine was, and you end up with 2,2-dibromopropane. One of the cool things about organic chemistry, which unfortunately you don't really get in a beginning class, is the puzzle of how to make something. Because what if you want to make 1,2-dibromopropane? You don't want both of these bromines on the same carbon. You want one on the first carbon and one on the second carbon. And so you've got different catalysts and different conditions, and you sometimes have to go through many steps. It seems like it would be easy, but it's not as easy as like building with Tinker Toys or Lego blocks where you can just pull this block off and put another one on. The molecules do what they do, and they have reasons, and we can't always control what they do. So let's look at these. Write equations for the following reactions. Here they're pointing out 1 mole of this. Just add 1 bromine to this molecule. Well, this is a symmetric reagent, right? So 1 bromine will add to the first carbon and 1 to the second carbon. So we'll end up with CH3, CH2, C with a bromine here. The double bond will stay. Well, I'm sorry, the triple bond becomes a double bond. That's adding 1. What's going to happen if we add 2 moles of chlorine to this other one? You could think of this in steps. First, you're adding 1 chlorine. And then when you add the second chlorine, that will add to that double bond. Oh, I did something wrong. Do you see what I did wrong? The first addition is trans. Well, I did multiple things wrong in this one. I'm ending up with the right product on this second one, but I didn't get the right product on the first one. Let's fix up this bottom one first. The first addition is almost always trans. And then the second, this is adding the second addition, and so this is our final product. In your final product, it doesn't matter That's really interesting that it's not the same as what's on my screen. Yeah, that's better. The final product, we end up with 2 chlorines on each carbon that had originally the triple bond. I did this one wrong up here. I did this one wrong because the first addition, the addition of 1 molecule of this should be trans, and I drew it cis. They're going to add to opposite sides.
Why
But-
is that?
Because we told you so. There's a reason, but it involves a mechanism, and we're not going there because you've seen enough mechanisms, haven't you? Yeah. It's an explanation like that. And we'll say, oh, okay. Yeah, the first one's trans.